Up to now, we are now confident on predicting the likely outcome if only demand or only supply changes on the equilibrium price and the equilibrium quantity. Looking at table 4.1, we are certain that if there is an increase in demand, only our supply will remain unchanged and both the price and the quantity exchange would increase. Likewise, if there is an increase in supply, only we are certain that our demand will remain unchanged and the price will fall whilst quantity exchanged increase. But then what happened if demand and supply change at the same time? We still Are we still able to predict the likely outcome with certainty? The answer is no, just simply because changes may work in opposite directions. This is a special case of a more general problem in economic theory. That is, when we allow one variable to change ceteris paribus, we are able to predict the likely outcome, but when more than one variable changes at the same time, we will not be able to predict the outcome, as these changes might work in the opposite direction. Looking at table 4.2, suppose there is an increase in demand and an increase in supply at the same time. What will be the likely outcome? We know with certainty that an increase in demand, ceteris paribus, must increase the price and increase the quantity exchanged. And an increase in supply, ceteris paribus, will cause the price to decrease and the quantity exchanged to increase. Therefore, when the two effects happen simultaneously, we can say with certainty that the quantities exchanged will increase, but what will happen to the price level is unknown, as both create effects that work in the opposite direction. Similar problems occur in other cases. Now let's look at this dilemma graphically, analyzing a simultaneous increase in demand and a decrease in supply. Prior, we know with certainty that an increase in demand, ceteris paribus, will cause a rightward shift of the demand curve, leading to an increase in the price and quantity exchange, whereas a decrease in supply, ceteris paribus, will cause a leftward shift of the supply curve, leading to an increase in the price level and a decrease in quantities exchanged. The combined effect of an increase in demand and a decrease in supply will certainly cause the price to increase than before, but what will happen to the quantities exchanged is unknown. Can you see that the demand effect is increasing quantities exchanged, whilst the supply effect is decreasing quantities exchanged? Therefore, the final outcome depends on the relative magnitude of the shift in the two curves. Suppose both curves shift with the same magnitude as in figure 4.3a, then the two forces will offset each other and quantities exchanged will remain unchanged whilst the price level increase. Suppose the supply curve shift with a greater margin than the demand curve as shown in figure 4.3b, then the quantities exchanged will decrease and the price level would increase. Suppose the demand curve shift with a greater margin than the supply curve as shown in 4.3c, then the quantities exchanged would increase and the price level increase. Therefore, from the three scenarios, it is now clear that with simultaneous changes, outcomes are not easy to predict as they depend on the relative magnitude of the shift in the curves involved. Just to summarize, a simultaneous increase in demand and a decrease in supply will raise the price of a product, but its effect on the quantity exchanged depends on the relative magnitude of the changes. As we see in figure A, the quantities exchanged remain the same, whilst in figure B, the quantities exchanged falls, and then in figure C, the quantities exchanged increased depending on the relative strength of the shift or the magnitude of the change in either the demand curve or the supply curve.